here Python's object orientation model described as being protocol-based. What does that really mean? Why is this an apt way to describe the different data model methods and how we implement them? Well, one perspective that we could take is if you look at how you actually go about implementing one of these data model methods, one of these underscore methods, one of these protocol methods, it's almost always the case that you'll implement it in terms of itself. You'll implement it in terms of itself as applied to either a constituent object or a base type. In other words, let's say you have a class base and a class derived that form some hierarchy, and you've defined len in terms of base, and you want to define len in terms of derived, so that somebody can create an instance of either one of these and ask these objects, what is your approximate size? How big are you? How many elements do you contain? Are you empty? Questions of that nature. And for whatever reason, you say, well, you know what, the length of this derived type is going to be slightly different than the length of this base type. Well, one thing that you might notice is you entered this protocol by using this built-in function len, and it triggered the execution of this data model method, len with 2 underscores before and after. And this is your hook point where you implement what this particular vocabulary means. And as part of that implementation, what you'll find is you'll often implement this len in terms of len itself. In other words, a very common way that you might implement something like this might say, you know what, call len on my most immediate base type, and I don't know, add 1 to it. Or if this happens to be a compositional class, where instead of using inheritance, you have some other piece of data that is made an attribute of this class, self.data equals data. And you want to say, okay, I think that there's a meaningful description of what the size of this type is. You'll define that in terms of the same len function, and you'll define this by delegating that same protocol to this constituent object. And so what you can see here is when we think about protocols, we often think about some set way to accomplish a task. And in addition to that, we think about some set way to accomplish that task wherein our responsibility is not to reconstitute that methodology from scratch, but instead to say, oh, you know what, in this circumstance, we just want to add this little piece on top. We just want to add this little piece on top. We want to define this using the definition of this protocol in terms of something that already exists. And so this is a common pattern that you'll see. But I want to show you another way in which we can think about what object orientation in Python means from this protocol perspective. And we return to our friend, the pandas DataFrame, in order to illustrate this. I want to show you a case in which we have two protocols that accomplish the same goal, but we can think about what the resulting meaning is by thinking about what the difference is between these protocols. One of the things that you can hear as we describe this process of implementing these data model methods is there is a very rote component to this. You say, I want to implement something that will respond to len, the built-in function. Therefore, I write a function called len with 2 underscores before and after. And inside that function, I call that len built-in function again, or I call super with that delegating to that double underscore len function. There's a mechanical aspect to this, but there's also a metaphorical and conceptual aspect. And that is, in Python, we have a set vocabulary, and it's a fairly well-defined vocabulary. And that vocabulary gives us the way in which the different objects in our system interact with each other. And so, for example, you can think, if you have some data frame, and you want to arithmetically manipulate it by adding it, well, the actual arithmetic operation that occurs here is very different than the arithmetic operation that occurs when you add two integers. Here, this is actually going to be index aligned. Effectively, what you're going to see is every element for matching columns in the left and the right-hand side, and every element for matching index labels in the left and the right-hand side will be lined up, and then it'll perform the addition. So this is a much more complicated operation than just adding two integers or adding two floating point numbers. But conceptually, this makes sense to us. And when we look at that code, we say, oh yeah, this is just an index-aligned df. You figure out what the common columns are, you figure out what the common index labels are, and you go and you implement them. When we see this vocabulary, we can get a sense for what the underlying intentionality of this code was, because the vocabulary lays clear, oh, I want to do something that can be conceived of as similar to arithmetic addition, subject to whatever the particular implementation characteristics are for that operation on, say, a pandas data frame, a pandas series, an NumPy and D array, including very complex mechanisms like broadcasting or index alignment, but still conceptually, basically the same thing as the abstract notion of addition. Well, we're given this vocabulary of the ways in which objects interrelate and the operations we can perform on objects. Len doesn't mean give me the length of some list or some tuple. It means give me the size of this structure, and this structure could be multidimensional. And so in the case of a pandas data frame, this could actually have some ambiguity. Does this mean the number of columns? Does this mean the number of rows? One of the things you can see is how pandas privileges taller structures over wider structures, because the answer to len gives you the total number of rows, not the total number of columns. You can see here, this is 10 and not 1, because pandas says, you know what, the length of a pandas data frame really is the number of elements in that index, not the number of columns. We have a particular conceptualization of what this means, and that affects the way in which we operate with this structure. This is why, for example, if we talk about the columns in the index of a pandas data frame, we might call one of these a major axis and one of these a minor axis, because operations typically prefer one of these axes over the other. Well, in any case, you can see that when you take a look at these structures and you take a look at this vocabulary, we're trying to express something to another human being reading our code. And the goal of object orientation in Python is to rearrange the complexity of our code such that we can express some intention for how we're going about to solve a problem in terms of some vocabulary that everybody can broadly understand, even if they are not intimately aware with the implementation details, and to have some mechanism by which we can actually go ahead and implement those. That's what these data model methods are. That's what these underscore functions are. Well, in some cases, there may be some ambiguity. For example, in a pandas data frame, we can access the columns by means of two different protocols. We can access this column, A, either via the getItem protocol, which would be implemented using getItem. It has this square brackets, and you give it some key. Or we can access this via the getAttr protocol. And the getAttr protocol, I think, is one of the most interesting protocols, and it's a very core part of Python. But you can see that there may be some ambiguity here. What is the difference between these two different approaches? Well, if you really think about what these two different protocols are and what they mean and what the restrictions are behind them, you can see that they map out a very clear and very distinct metaphorical meaning. For example, when you think about getItem accepts any key, meaning I can put any arbitrary value as the key of this getItem. I could put, say, some ellipsis object, I could put some tuple, I could put some slice object, and you've seen all of these mechanisms in use when you do your different indexing modalities in your NumPy and D array. Here I could have a tuple. I could even have, say, a dictionary, and you may have even seen this structure in tools like Xarray. And so here I have a set, or I could have a dictionary, and anything is basically fair game for the getItem protocol. What we can think is the actual thing that you're using to perform the lookup, the key, the element that you're putting into this protocol in order to retrieve some output, this input, is unbounded. It could be any arbitrary value. And so one thing that you can think is the getItem protocol corresponds to a lookup where you're looking up using some unbounded possible set of keys. Typically, when we talk about these unbounded values, we're typically talking about some sort of data. We're talking about something that we've read in here, but we haven't manually input. We may not have looked at directly. We may not even have checked. We're just kind of passing from one part of our program to the other part of our program. And you can think that this more or less corresponds to the getItem protocol, conceptually and also mechanically. When you think about the getAttr protocol, well, the actual key, the attribute name that the getAttr protocol can take must be a valid Python identifier. And so if you had a pandas column name, and that column name happened to be something that started with a number, you can't use this particular protocol in order to look this up. If you happen to have a pandas column name, and that pandas column name started with anything but an underscore or a letter, that's not valid. If you had a pandas column name, and that pandas column name, for example, had some sort of tuple structure to it, because pandas column names are just an index of their own form, and so they can have any arbitrary value. Well, there's no way for you to use the getAttr protocol in order to access this. Similarly, when we think about these different protocols, we can also think about what are the general expectations that somebody would have. When you see square brackets, you often think things like a list or a dictionary. And this strongly informs our understanding of this protocol. Well, when we think about a list or a dictionary, we often think if I'm accessing the contents of a list or a dictionary, that accessing might fail. The list may only have 10 elements and I've tried to access the 12th element. I'll get an index error. Or the dictionary may only have certain key value pairings and I access a key, but that key doesn't exist and it gives me a key error. One of the common assumptions we have when we think about get item is this is a lookup that is on some unbounded key where we should generally be aware that that key might not exist and this lookup may fail. Whereas when we do getAttr, which we do all the time in Python, we very rarely try to capture an attribute error because you can think with the long chains of attribute lookups that you might do in any arbitrary given program. Think about all the different methods that you might chain in the manipulation of a pandas data frame. Are you really looking for an attribute error on every single step? Of course not. And so one of the general assumptions for getAttribute tends to be that even though this attribute lookup might fail, we tend to assume that that is indicative of some sort of fundamentally mistaken assumption. Something is wrong at a systematic level, not at a data level. We've introduced some sort of bug, we have written something incorrectly, there's a mistake, or some assumption of something that should be there simply is not there, and it's supposed to be there. And so one thing that you could surmise from this is that even though, in the case of a pandas data frame, where you have columns, and those columns do not, for example, overlap with existing entities in the pandas data frame. For example, you can't use this protocol if you have a column whose name happens to be index, because then there's an ambiguity. Do you mean the index attribute on the pandas data frame itself, or do you mean the column that happened to be named index? But setting that aside, one of the distinctions you can see here is, do you anticipate that that column will exist, assuming, of course, that it's named in such a way such that either of these protocols can be used? And structurally, as part of the code, is it considered significantly erroneous at a systematic level if that column doesn't exist? Or is this column just merely some data that might exist, might not exist? This lookup might fail, this lookup might not fail. And so one thing that you could consider here is when people deal with pandas data frames, there's actually these two different conceptualizations of what the columns of the pandas data frame mean structurally. In some cases, in some of your use cases, you've seen all of the functions in our code base assume that this pandas data frame must have this column with this specific name, and this specific name is short and is a valid Python identifier. And if that column is missing, our code breaks in very significant ways. Therefore, the presence of this column is an assumption where if this getAttribute protocol fails to access this column, that's a systematic error. And in other cases, you might have pandas data frames where you say, oh, maybe it sometimes has a column named this, maybe it sometimes has a column named that. It might be here, it might not be there. And as a consequence of using the getItem protocol, maybe the naming of that column is a little bit more free form. It doesn't have to be a valid Python identifier. It doesn't have to be a string. It could be any arbitrary object. But fundamentally, as part of what you're encoding by using getItem, in order to access this column name, you're suggesting this column is not a structural assumption of the underlying data frame. It's merely some data that might be there, might not be there, and we'll have to deal with whether it is there or not there. Now, this level of distinction that you might see between looking up a column using getItem, getAttr, in practice, most data scientists just aim for whatever is less typing and whatever they can get away with. But fundamentally, what you can see is through a process of looking at the limitations of these protocols, we can derive fundamental meaning that can guide us in terms of what is somebody going to see and understand implicitly from the code that we've written in terms of the overall vocabulary that these different protocols provide to us. What do these protocols convey? And how do they fit into a common meaning of Python? This is why we might call Python's object orientation model protocol-based. It's about a set of different mechanisms that have a rich conceptual meaning and a common way in which we implement those by delegating to a base type or delegating to a constituent object and a particular set of mechanisms that are involved and a consistent set of mechanisms that are involved as part of that implementation. I think the get attribute protocol is probably one of the most interesting protocols, and I think it's worth looking into further. Stay tuned for a future video when we'll take a look at the details of the get attribute protocol, including things like the method resolution order, including things like the descriptor protocol, including how instance methods, class methods, static methods, and properties work. Stay tuned. I think you'll enjoy it.